In this video, I will show you that we could not use the direct comparison test that easily to show that this series converges or diverges. So here we have the sigma when n goes from 1 to infinity, n over 5 to the n. Remember the strategy when using the direct comparison test. We need to come with something that's easier and then we know much better right away, right? If we look at n over 5 to the n, too bad that we had an n on the top. Imagine, wouldn't it be much better if we just have 1 over 5 to the n instead? Because we know that much better. We know that if we have sigma when n goes from 1 to infinity, 1 over 5 to the n, this is the same as saying sigma when n goes from 1 to infinity, parentheses 1 over 5 raised to the n power. And then this is a geometric series where the common ratio r is equal to 1 over 5, and then we know that this is less than 1, therefore this right here converges. But then the one that we had earlier had n on the top. This was not a geometric series. And now let's try to use the direct comparison test to see if it will work or not. And then what we do for the direct comparison test is that if we have a convergent series that we know, the way to set up the inequality is that we put down the original on the left-hand side. We hope to show that the original series is less than or equal to a non-convergent. If we can show this is true, then we get to use the direct comparison test. Let's see what do we get. So let me put on the original right here, sigma when n goes from 1 to infinity, n over 5 to the n. We would like to know if this is going to be less than or equal to the convergent series that we know, which is this one. Sigma when n goes from 1 to infinity, 1 over 5 to the n. And then because both of them go from 1 to infinity, I can just compare the expressions n over 5 to the n and then 1 over 5 to the n. Is this smaller or equal to this? For n is bigger than or equal to 1 because n goes from 1 to infinity. Well, this is clearly false, especially after we multiply both sides by 5 to the n. This cancels with that, 5 to the n cancel with this and that. And then here we are saying n is less than or equal to 1, which you see this is a contradiction. Here we need to have n is less than or equal to 1. But then here we are saying n is bigger than or equal to 1. So this right here is false. Because the inequality doesn't work right here. Therefore, we know that the direct comparison test won't apply. So unfortunately, too bad. And that's why we can try to use the ratio test. And for the ratio test, the advantage is that we do not need to come up with another series. We just look at the series that we have, and then look at the next term where we have the an plus 1. We compare the an plus 1 and then divide it by an and take the ratio when n goes to infinity and also the absolute value, and then we go from there. But then in this video, I just show you that the direct comparison test won't work in this situation because the inequality doesn't hold right here. This is it.